Let us continue with polarization by absorption. From what we have learned before, we know that the equation that we can retrieve from the polarization, or if there is more than one polarizer, is the Malus' law equation, which is I is equivalent to I naught cos squared theta. For example, if let's say I have the first polarizer here, I have two polarizer here. One is at a horizontal slit, another one at an angle. So the angle between the horizontal slit and the other slit, that will be the theta. So this theta is the angle between the two slit, or between the two polarizer. This is we are going to use inside the Malus' law equation, right? And then of course we have our I and I naught. I will be the polarized light, or the intensity of the outgoing light after passing the polarizer, the final intensity. Whereas I naught will be the intensity of polarized light incident on the analyzer. Meaning, for example, if let's say light goes in from here and then it passes through the first polarizer, so this will be your I naught. Okay, and then once it passes through the second polarizer, this will be your I1, or your I. So from these two, I can get the Malus' law equation of I is equivalent to I naught cos squared theta. I'm going to show you later on how you're going to use how are you going to calculate the cos squared theta equation. Right. So the intensity of the transmitted beam is maximum when the transmission axes are parallel towards each other. So because once they are parallel towards each other, they are either at 0 degree or at 180 degree, meaning the intensity will be maximum. Because if you calculate cos squared 0, okay, how to calculate that? Make sure you calculate cos 0 first, and then you square them. So cos 0 will be equivalent to 1. Of course, once you square them, that will be 1 as well. So that's why it is maximum. But if it is perpendicular towards each other, so just now parallel towards each other, for example, first polarizer is vertical, second polarizer vertical. So that will be maximum intensity of light transmitted. If let's say I'm going to put this perpendicular towards each other. One is horizontal, the other one is totally vertical. So horizontal and vertical will give you 90 degree angle. So take out your calculator now, calculate cos 90. You will get 0, meaning there will be no light transmitted. This will cause complete absorption, meaning if let's say I have 100% intensity of light, it goes to the first polarizer. Okay, if let's say 100% intensity of light, then it goes to the first polarizer, it will only be left with half of the intensity of light. So half of I naught, sorry. So it will be left with half the intensity of light. So let's say this is the initial intensity, this will be I1. And then the last intensity will be I2. So if let's say the theta is 0, I will get I2 is equivalent to I1 cos squared theta, which will give you 0 here. And the final intensity will be 0, meaning the light is completely absorbed, 100% polarized. Okay. Alright, unpolarized light consists of light with random direction of polarization, like with what we have learned before. It has vertical component and horizontal component. On average, an unpolarized light can be thought as a two-plane polarized beam of equal magnitude perpendicular to one another. When one unpolarized light passes through a polarizer, the other component is eliminated. So always, once it passes through the polarizer, there will only be half of the intensity. So intensity of light passing through is reduced by half. So no matter how many polarizer you have, for example, I have 3 polarizer here. Okay, always put the light here. Once it passes through the first polarizer, let's say this is my I0, this is my I1, I2 and I3. So the light at I1 should always be half of I0, which is the initial intensity. Okay, Alright, so this is another example. For example, this is another example. Polarizer 1 has a vertical component, has a vertical slit. So only the vertical component will passes through. So as you can see here, this is vertical component. So once it passes through the second polarizer, which is horizontal, it will not pass through at all, meaning there will be no intensity left, or it's called complete absorption, meaning light is fully polarized. Okay, so this is another example that you can look at. The intensity of light transmitted through two polarizer depending on the orientation of the transmission axis. Just now we were just looking at the component. Now let's look at how it will look like if let's say you passes light through. Let's look at A first. The transmitted light has a maximum intensity when the transmission axes are aligned with each other. This is what we have learned here, where it has mentioned that when both transmission axes is parallel towards each other, they will give you maximum light. Or in easier word, light was not polarized. You can still see the light as it is. So vertical, you can see that this part here is just the same as it was before. Okay, let's look at B then. Okay, the transmitted light has a lesser intensity when the transmission axes are at an angle of 45 degrees with each other. Meaning, the first polarizer is at a certain angle, second polarizer is vertical. So the angle between these two polarizer is 45 degrees. Meaning, half of the light will be transmitted from the both polarizer. So you can see the light here a bit polarized, or it's a bit darker, pretty much like your sunglasses, where once you wear the sunglasses you can still see everything around you, but slightly dimmer because some of the light has been polarized. Let's look at C then. The transmitted light intensity is a minimum when the transmission axes are right angles toward each other. Right angle meaning they are perpendicular towards each other. Also the same from what we have learned here, where when both transmission axes are perpendicular, it will give you zero intensity of light, or easier word, no light will pass through, completely polarized. So you can see total darkness there. So note there that LCDs are made of a liquid crystal containing between two polarizing surfaces. That's why if an LCD TV, it's very hard if you have ruined the screen of the LCD TV. Usually they will suggest you to just buy a new TV, because for them to replace the two polarizer inside the LCD TV, it will be quite expensive. So that's one of the example in our daily life. Right, so when two polarizers are crossed, their axis perpendicular to another, unpolarized can be entirely stopped, from what I've mentioned just now. Or, easier word, there will be no light passing through. If another polarizer at an axis of 45 is placed between the two perpendicular polarizer, light will pass through. Meaning, just now I have my first polarizer here, and I have my second polarizer here, and then I brought the third polarizer and put it in the center of the in between the first and second polarizer. So this third polarizer is not vertical or horizontal. It is at an angle of 45 degrees. So how do I calculate the final intensity? Okay, first, the light coming in, we have to label it as initial intensity, or I0. Second light passes through here will be your I1. Okay, from the second polarizer, this will be your I2. And then the last polarizer will be I3. So we have to calculate it one by one. First of all, let's look at I1 and I0 first. So I1 will also be equivalent to I0 cos squared theta, which was the equation that we have learned before. But remember, for first and second polarizer, for the first polarizer, there is no angle before that. So you cannot apply cos squared theta. Simply put, I1 is equivalent to half of I0. That will always be the value of I1. Okay, then let's look at I2. I2 will be I1 cos squared theta. So you can substitute your I0 here. Oh, sorry, your I1 here. So that will be half of I0 cos squared theta. Or you can put the angle just now between I1, I0 and I1. Sorry, between I1 and I2. The angle between here, because we are using I2 and I1 here. So the angle between will be vertical and then 45 degree. Meaning your theta is 45 degrees. So put here 45 degree. Half of I0 cos squared 45. When you key in those values in your calculator, calculate your cos 45 first. So cos 45, you get 0.707, and then you square them, you get 0.5. So times another half just now from the I0, you get 0.25 or 1 over 4. So you will get here I2 is equivalent to quarter of I0. Sorry, quarter of I0. So you see there, from half it has become quarter of I0. Now we are going to calculate the final intensity of I3, which is equivalent to I2 cos squared theta. Again, simplify the equation. I2 just now was quarter of I0. So quarter of I0 here, cos squared 45. So cos squared 45 will give you 0.5. So 0.5 times 1 over 4. You will get 0.125 or 1 over 8 of I0. So your final intensity will be 1 over 8 of I0. Okay.